Hello everyone, today me and my teammates Kashmita Koyala, Pishika Chetri and Shreya Brathuki are here to present on the topic Logistic Regression as required for our assessment. Have you ever wondered how Gmail knows which emails are spam, or how Netflix seems to know what you want to watch next? Behind the scenes, there's a tiny detective working all the time, and its name is Logistic Regression. Today, let's find out how this detective makes a yes or no decision. Logistic regression is a method that helps us predict yes or no outcomes based on data. Unlike regular regressions, which predicts continuous numbers, logistic regression predicts the probability that something belongs to a particular category. In today's presentation, we will cover the following topics. So first, let's discuss why do we even need it. Some problems only have two possible answers, yes or no. For example, is the email spam or not? Will a customer buy a product or not? Is the patient sick or healthy? Logistic regression is designed exactly for these kinds of binary choices. Now that we know what is logistic regression, let's talk about how it works. So how does it actually make these predictions? Here's the cool part. Logistic regression doesn't just guess yes or no, it actually predicts probabilities. For example, I'm 90% sure this is spam is marked as spam and I'm only 10% sure is kept in inbox. So we don't just get a decision, we get how confident the model is before making it. And how does logistic regression work? Let's break it down step by step. Step 1. We collect information like how many suspicious words are in email or if it has links. Step 2. We multiply each piece of information by its importance. These are called weights and add them up to get a raw score. Step 3. We pass that score through a magical function called sigmoid, which converts it into a probability between 0 and 1. Step 4. If the probability is above 0.5, we say yes, otherwise no. But wait, what exactly is the sigmoid function and why does it matter? It works by turning any number into a value between 0 and 1. High numbers are close to 1, which is a yes, low numbers are close to 0, which is a no, and middle numbers around 0.5 is a maybe. Sigmoid creates the famous S-curve of the logistic regression. As you can see in the diagram, on the left it is definitely no, in the middle a maybe, and on the right definitely yes. To understand better, let's see this in action with a real-life example. Let us say you just got an email. Logistic regression checks how many spam words it has, whether it has suspicious links, and even the sender's reputation. It combines all of this information into a score, passes it through the sigmoid function, and gets, let us say, 0.85. Since 0.85 is greater than 0.5, it confidently says, yes, this is a spam, and sends it to the spam folder. So why is logistic regression so important? First, it is simple and very fast to learn. Second, it is easy to understand. Even someone without a math background can follow it very easily. And third, it gives us probabilities, not just a yes or no, which helps us make us better decisions. That is why it is used everywhere, from spam filters to fraud detections to medical predictions. But of course, it is not perfect. It only works for problems with two possible outcomes, yes or no, unless we modify it for more classes. It also struggles with very complex patterns where advanced models like deep learning perform better. And just like any model, it needs good, clean data to make good decisions. So, to wrap it up, logistic regression is a yes-no decision maker that predicts probabilities between 0 and 1. It uses the magical sigmoid curve to keep its predictions in range. It's simple, powerful, and quietly helps us every day, whether it is catching spam emails, detecting fraud, or making recommendations. We hope you liked the presentation and thank you for staying to the end of it.